Welcome. Let's go ahead and talk about the Blockchain Training Alliance exam, specifically the Certified Blockchain Solutions Architect exam. When it comes to blockchain certifications, the Blockchain Training Alliance clearly is a leader in this area at the time of writing. When it comes to getting certified, the CBSA is going to be the entry point for most folks that are looking to get certified in blockchain technology. We'll talk about the top 5 reasons to get certified with BTA, and then I'll talk about some other resources to help you prepare for this challenging but also rewarding examination. When it comes to training, I want to just go ahead and talk about my experience and help you identify some credentials that I have. I've been a certified blockchain solutions architect as well, and I'm also one of the first ones to get certified in that area. I'm also a certified blockchain expert as well as a certified Bitcoin professional. I'm active in the cryptocurrency areas as well as the blockchain areas as well. I'm also a well-known author around cloud platform technologies such as Google Cloud and Amazon. When it comes to taking the exam, the first thing you want to know about the exam is the cost. Of course, the cost is a little bit steep. However, it's worth the $300 if you're looking to provide a baseline accreditation certification, that is, to your potential employer or to your customer base. The reality is that there's no other cert right now that I'm aware of that actually you go to a testing center and validate your credentials. Now, that of course is going to change, but for the time being, this is a very well-written certification, and I was pleasantly surprised to see that. Let's go ahead and take a look at the website before we get going. I'm over here at the Blockchain Training Alliance website. Now, to clarify, they have specific certifications that are a little bit more specialized as well. When you go over here to certification, you'll see that they have the Solutions Architect, the Ethereum Developer, and the Hyperledger Developer as well. When it comes to training, there's also options out there for training, such as courses with the Blockchain Training Alliance. If you go over here to classes, you'll see that they have a number of classes. If you're looking to take a formal class around the CBSA, I encourage you to take the blockchain architecture training. Now, this is actually very competitively priced, and the reality is that it is well worth the level of effort that you'll put into it. And they do run these frequently as well. When you go over here to course overview, you'll see what the course is about, the prerequisites, what they're going to cover. And if you study this, and to be very honest, you can go ahead and study these areas, and you will do just fine without taking the course if you do actually study the right areas, and you can actually look at the outline and be able to assimilate what they would probably ask you around specific areas. So with that said, I would encourage you to take the class, but if your company isn't able to pay or you're not able to foot the bill, then you could certainly do what you can to study as well. Now, there's also a book as well that you can also purchase, and I'll show you where that is as well. If you go over here to the Solutions Architect, you'll see that they have an exam study guide. This is essentially a condensed practice question book with some study material. If you go over here, the cost is actually very reasonable. It's only 51 pages, so you're not going to get a whole course or anything in it, but it's enough to give you an idea of the outline. And it does have a practice exam as well. Now, the exam itself is $300. You do go to Pearson to take the exam. When you take the exam, you will be notified immediately after you submit whether you passed or not, and you will be, of course, rewarded or not rewarded, depending on how you do, passing the exam or not passing. When you do pass, you'll receive a token in the mail saying that you are a CBSA certified professional with the Blockchain Training Alliance. Now, that is the website. Let's proceed on and talk about the exam itself. Now, the exam was written in a concise manner. Basically, everything did match the objectives. One of the things that, if you look at my LinkedIn profile, for example, is that I've got a well-versed area in technical training, course development, and test development as well. And I can assure you that they did a very professional job. Everything was well edited and clearly much better than the other certifications I've seen on the market from other organizations that clearly didn't put in much of a level of effort and we're just cashing in basically on the demand at the time of writing. Now, when it comes to taking the course, it's a 3-day course. However, like I said, you could certainly pass this without much effort. And I do have a course being developed for at least one platform at this time as well. When it comes to the certified blockchain solutions architect, you would definitely test it on the blockchain basics. For example, how is a block written? What a nonce is? What is a permission-based and a permissionless-based blockchain? You also expected to know the basics of Bitcoin, Ethereum, Hyperledger. Now, I didn't see anything on R3/4 Quantum, for example, but you want to know the discussion points. For example, why would you want to use Hyperledger over Ethereum? Or, for example, what about if you're using Ethereum, do you have to use tokens? Or if you're using Hyperledger, do you need to use tokens? Does Hyperledger have a token, a native token, for example? No. But can you use tokens or cryptocurrencies with Hyperledger? You can certainly build that in. Remember, Hyperledger is modular, and we'll talk more about that and some of the other modules I'll be doing around this. You have to know the use cases. That's really what I'm trying to get at here. Understand where Ethereum falls in, where Bitcoin falls in, and where Hyperledger falls in as well. But also, too, understand permissionless and permission-based. That sort of falls into number 3 as well. Now, the exam certainly did match up to what I would call the pre-sales requirements. I've had the opportunity, of course, to sell tens of millions of dollars in data storage equipment as my time as a pre-sales engineer. And I can rest assured that if you're working for a vendor or a VAR, you're going to need to know this area sometime down the road. And the reality is that jobs need to be outsourced, they need to be removed because companies are not making money. And the reality is that when it comes to being on the front lines, you have to be able to sell the technology, but you have to know the business case for the technology as well. And the blockchain is going to be disrupting a lot of industries. And if you're not sure of those industries and why, then you might not want to be taking this exam yet, because again, you should be expected to know some of this. Now, when it comes to an integrator, for example, just be aware that if you're a VAR, a value-added reseller, even an ISV, for example, in some cases, you need to understand that the blockchain is going to disrupt some of the industries. For example, we're already seeing it in the financial sector. When you have an intermediary and that intermediary can be removed and you can cut costs, the executives are going to go for it. The company officers are going to go for it. It's just a fact. And the reality is that there's good examples already in sort of past the beta mode, like Ripple, that are actually reducing the cost of transactions between interbanks, for example, and reserve banks for that matter. With that said, just look at some of the use cases that are out there and picture where things can go, because it is going that way. When it comes to knowing, for example, cryptography, now knowing some of the technical areas you're going to need to know, let's go ahead and talk about some of these. Now, for example, with PGP, I'm sure you're already aware that you have a public key and a private key. The goal of the public key is to lock or encrypt the message, and a private key is generally to decrypt or unlock that message. Now, PGP was originally developed in 1991, I believe, and was sold essentially to Symantec at the time. Now, there's open source versions of PGP, for example, but you don't need to know all that for the test. But just be aware that PGP is an encryption process and a decryption process as well. And a fair number of the cryptocurrencies and blockchain technologies do use this technology. So just be aware that PGP encryption at a high level you'll want to know more about. Now, hashing, again, is going to be a little different. When it comes to hashing, you'll want to know that hashing, for example, is really not going to be something that can be decrypted. So, for example, you're going to take a bunch of bits and bytes, and you're going to go ahead and scramble those essentially, which is essentially hashing. And you're going to go ahead and encrypt that essentially. Now, you can't decrypt that hash, essentially. That's really the main difference between encryption, cryptography, and hashing. So think of cryptography as being able to be encrypted and decrypted, but hashing is really a one-way process. Now, number 6, this is where the bulk of, I think, the technical area will really rest in, is to understand where the consensus algorithms fit in and why you want to use different proof of work, proof of stake algorithms. And again, just be aware that on the exam itself, you'll need to contrast proof of work and proof of stake. Remember that proof of work and proof of stake are vastly different and have very different benefits in a lot of cases. So let's go ahead and talk about this. Now, with proof of work, this is really more of a level of effort. There are some terms out there in the mining, not really mining industry per se, but the Bitcoin mining industry, for example, that the more compute power you have, the more money that you'll likely make because you're able to solve problems quicker. And the reality is that proof of work is basically defined by the calculations that you're able to process as quickly as possible. It's really a race is really what it is. Now, proof of stake, for example, like in Dash, you need to put up, funds to be able to, or tokens basically, to be able to participate in that specific mining process, to be able to essentially create new blocks. It's basically a deterministic way is another way to look at it. So basically, if you have more wealth, you have a bigger stake. That's generally at a high level how it's looked at. However, in reality, every one of the different platforms that use like proof of stake have it implemented slightly different. Now, there's also some other algorithms. Let's go ahead and talk about those as well that you may see on the test as well. For example, like instead of like proof of stake, there's also delegated proof of stake. And this is a protocol that generally allows the token coin holders to use essentially the balances that they have to elect what's called a delegate. And a delegate is typically known as a witness as well in most of the platforms that use it. These witnesses, for example, can essentially have the opportunity to stake blocks of a new transaction and add them to their blockchain. And it's really voting power is really really determined by the wealth effect as well. For example, again, it's very similar to what you would see in politics. Again, if you're just a citizen, you're not going to have any real vote power, but if you're a major corporation or really wealthy, you could pretty much buy your results if you want to donate to the right crowd. And it's very similar to that. It really, in my opinion, is part of voting power. Now, there's also, witness, delegates. Some of these terms are confusing, but at a high level, just realize that a witness is really a delegate in most of the DPoS algorithms as well. Now, some of the benefits of DPoS, for example, is that you have, a little better distribution of the rewards, and you generally do have better voting security because, again, the other voters can detect that there's an issue. Now, there's, of course, some challenges with that as well. You could, have attack issues like the 51% issue, like with the proof of work that could happen. Again, that's just one of the issues that could result. Another algorithm I didn't put on there is also known as LPOS. That's called the least proof of stake. This is a very uncommon one, but it is out there occasionally. For example, this is basically where it's a decentralized platform that generally allows you to create customized tokens. You could certainly use this with Hyperledger, for example, and basically the nodes will become stronger when you essentially allow the blocks to be written to the blockchain, and the rewards that are received are generally distributed as well to the winning node. And then there's another one called proof of elapsed time, POET. I won't go into every one of the algorithms, but I did want to point out number 7 as well for time purposes. You should know what the Byzantine fault tolerance is. This is really important. Again, BFT, as it's known, is very popular with permission blockchain platforms. It's used with Hyperledger Fabric. It's also known as the practical Byzantine fault tolerance as well. And again, if you're familiar with Hyperledger, then you're already aware of the Byzantine general problem, and you're probably aware that, how do you get all these generals, to work together, and how do you trust that this general is actually not an intruder or your enemy. But with that said, just be aware of what BFT is. Let's go ahead and speed it up and talk about tokens and coins. When it comes to adding value, the blockchain definitely can add value with tokens and coins, especially if it's a permission-based blockchain. Now, Hyperledger does not have a native coin. However, if you need to use Hyperledger, want to add a coin or a token as a use case, you can certainly do that. Now, another area that you'll want to know is Ethereum, ERC20 and ERC721. You have to know these areas. Understand that ERC20 and ERC721 are actually very different types of tokens, and do know what is fungible and what is not. I'll let you study that. How's that? When it comes to the CBSA, terminology is key. I would say, and I'm guessing I didn't totally think this one out before going through this, but I would say about 20 to 25% of the exam is going to be on terminology. Understanding the difference between a database and a ledger, what is centralized, what is decentralized, what is immutable and what is mutable, distributed and not distributed. A lot of terminology. What is a nonce, right? A lot of blockchain-based terms that you'll need to know. Also, you need to know at a high level how you could develop and test on Ethereum. One of the areas that I was surprised, but pleasantly surprised to see, was the level of depth around Ethereum that they had in the exam. For example, testnets. There's different testnets. You're going to need to know these. You'll also need to know MetaMask. You'll need to know what Mist is. You'll need to know Remix, Ganache. For example, how do you develop? How do you test on Ethereum? If you have any questions on this, take the course, get the book. I've got practice questions to help you study as well. Once again, look at it from this perspective. When it comes to development, again, know what a persona is, know what guiding principles are, and what the use stories are. When it comes to use cases, again, know why you may want to use a smart contract and maybe why you don't want to use a smart contract. Remember that a smart contract is not a legal document. It is not something that's legally enforceable, but it's computer code that essentially is going to execute when a condition is met. However, a smart contract could be legally enforceable in some jurisdictions, but in general, it is not really a legal contract in most cases. So just be aware of that. Don't get confused over that. So do know the difference between a smart contract and a legal contract. This will help you understand where a use case for a smart contract could be. Let's talk about the top 5 reasons to take the CBSA now. It's the first to market that was professionally developed. Again, there's plenty of other blockchain certs out there, but the other ones, you don't go to a testing center or they were just sort of rushed to market. This was clearly well thought out and invested in. The BTA also has several training options as well that complement the cert. For example, they have Ethereum and Hyperledger developer certs as well. It was clearly written by experts. No question about that. If you're into pre-sales, solutions engineering, or even in technical sales, you really should consider this certification. This could definitely change your view of the blockchain and also help you understand the dynamics that are going on in your market, such as financials and government sector. Number 5, you should get a blockchain cert just because of the fact that your coworkers are probably considering this as well, but also this will help you distinguish your level of expertise. The reality is that your job is going to be more competitive to compete and to have and maintain as well. Demand is hot. There is no question about it. There's a nice article that goes through blockchain job roles. I would highly encourage you to take a look at the Hacker Noon article. I have some practice questions as well that are here in case you are interested on Udemy to help you prepare. The link for those practice exams is also in the YouTube description as well. Now, the Blockchain Training Alliance has a wealth of courses. We covered these as well. I did want to point out they also have the top 10 blockchain roles that are out there. You could see them listed there as well. Tells you about the demand as well. That is interesting. Now, one of the questions I get is around blockchain expertise and how do you get into the blockchain? Well, this is really a multifaceted question, but the reality is you have to learn about it first and start making your own ways. Get certified, get out there and look for roles that require some kind of blockchain knowledge. You'll get your foot in the door because the reality is, in a lot of markets, there's definitely more demand than people. On the other hand, it depends on your marketplace. If you live in Jacksonville, Florida, you might as well just write it off. But on the other hand, if you're willing to commute every week or go to New York City or other areas like San Francisco where it's hot, and London, Singapore, then you have lots of great opportunities. If you're a programmer, you could do this from anywhere, to be honest, and there's a lot of remote roles as well. Some of the areas that if you're a developer, I would encourage you to consider is going to be evergreen, C++, JavaScript, PHP, Ruby, Python, and Solidity. Now, Solidity is the Ethereum blockchain development language, essentially. Now, when it comes to careers, these are just some of the roles that you'll see. Again, there's plenty more. The Blockchain Training Alliance did a nice slide as well. When I looked at LinkedIn at the time of writing, there's over 1,700 roles in the U.S. requiring blockchain knowledge. Now, this is up considerably from last year as well. Again, if you go to LinkedIn, you'll see that there's plenty of roles. I've added some resources here to help you dive more into blockchain. Another area I'll do some training on is going to be blockchain as a service. As a cloud computing expert for years and years, this is an area that sort of correlates really well with me. And thank you again, and please do reach out if I can be of assistance and if you have any comments or questions.